Welcome to Intercepts of a Graph. Today we will be talking about rational functions and how to find the intercepts of a graph. Well, it turns out finding the intercepts of rational functions is no different than finding the intercepts of any other function. It doesn't matter if it's lines, quadratics, absolute values, or any other type of function you're dealing with, you always find them the same way. To find an x-intercept, that is to say, a place where it exists on the x-axis, because it's intercepting the x-axis or whatever, you set y equal to 0, because all of these points right here have a y value of 0. So it should make sense that y equals 0. And same thing here, if you have a y-intercept, the x value is always going to be 0. So algebraically, you just plug in 0. And that's all this is right here. So it is important to note that at least for rationals, it is possible for there to be no intercepts because of the asymptotes. If you have an asymptote on the x-axis, it's not exactly possible to have an x-intercept there. Well, technically it's possible. But, if it's going like this, it's not going to have one. Like, there are graphs that look like this. Asymptote here, asymptote there. It looks like this. And as you can see, this has no x-intercept. It does have a y-intercept, but it does not have an x. So it is possible for there to be none. And that'll just happen algebraically, so you'll see. So to find an x-intercept, you set y equal to 0. And you'd have y equals 0 right there. The thing is, with fractions, like I'll say this and either it'll make sense or it won't. If it won't, I'm going to explain it afterwards anyway. But it should make sense that in a fraction, when you divide fractions, the only way to get 0 in a fraction is if the top is 0. Like this. What is 0 over 5? What is 0 over 3? The answer is 0. 0 over anything is always 0, which means as long as the top is 0, it'll automatically be 0. Mathematically, what you would do is you would multiply both sides by x minus 5 to get rid of that. And then 0 times this thing is just 0 again. But just note that this looks exactly as if you just make the top equal to 0. And that's 100% going to be the case every time. So really, what you can think about for x-intercept is just set the top equal to 0. It's just a trick. Mathematically, what you do is you're multiplying and then you get the top, but you can just go straight there. If the top equals 0, that is it for the x-intercept. So subtract 2, x equals negative 2. So the x-intercept is at negative 2 comma 0. And I'll do x-intercepts in blue and y-intercepts in red. Color coordination. Same thing here. If I just set the top equal to 0, then I would subtract 2 to get 12x equals 2, negative 2, and divide by 12, and I would get negative 2 over 12, which is negative 1 over 6. Sorry. So at negative 1/6, comma 0 would be my x-intercept. Okay, that's that. Excuse me. I'll do, I guess, one more. Here, if you set the top equal to 0, it's factorable. It factors into x plus 1 and x plus 1. Top equals 0. In which case you get x equals negative 1 twice. So you can just write negative 1 comma 0. You don't have to write it twice. So those are the x-intercepts for those. For the y-intercepts, it's a bit easier actually. Setting x equal to 0. If x equals 0, then 0 plus 2 is 2, and 0 minus 5 is negative 5. So you get 0 comma negative 2/5. Here, if x is 0, then 12 times 0 is just 0. So you get 2. and then 0 squared plus 3 0 squared minus 4. Remember, you're plugging in 0 for x, so this is going to be 0, this is going to be 0, and you just get negative 4. So 0 comma simplify to negative 1/2. And lastly, same thing, 0, 0, those just go away and you get a 1. 0 squared, 0, 0, 0, 4. So 0 comma 1/4. In typical fashion, I'm just going to go ahead, zoom out a little bit, recommend to you that you try these, and then I'm just going to go ahead and do them, but I'll do them kind of fast because I don't want this to be forever, and you can always rewind it if you don't like it. Okay, so here we go. For x-intercepts, we set the top equal to 0, so we get x equals negative 2, so negative 2 comma 0. This one down here, setting the top equal to 0, don't know, so there's none. Like I said, it's possible. Down here, if you set equal to 0, you have to factor it. This will be a 6 and an 8. It'll be a negative 8 and a positive 6. So you get x equals negative 6 and x equals positive 8. So you have two intercepts, negative 6, 0 and 8, 0. Yay. X-intercepts here, you would subtract 2. If it's equal to 0, subtract 2 and divide by 3. Subtract 2 and divide by 3. So negative 2/3. Here you would set this equal to 0 and add 2, so you get positive 2. Okay, going back and doing the y-intercepts. If you plug in 0 here, you get 2. Plug in 0, you get negative 5 times 0 plus 1 is 1. So negative 2/5. Here, plug in 0, the top is still just 2. This will be 5 times negative 1, right, 0, 0. So 0 plus 5 is 5, 0 minus 1 is negative 1. So 2 over negative 5. That looks familiar. Like so. Here, 0 minus 2 is negative 2. 0 squared minus 4 is negative 4. So negative 2 over negative 4 is positive 1/2. And lastly, 0, 0, negative 48. 0, 0, negative 32. That definitely simplifies, I think, by 16. You can divide them by 4 first or something if you want, but I think 16 goes into them both. This will be a positive. 16 goes into that 3 times, 16 goes into that twice. So you might have simplified it differently, but if you divide them by 4, you get 12 and 8, and then, divide those by 4, and you get 3 over 2 again. So there you go. Okay, hope this helps. Hope you like it. Have a great one.